All right, we're live. So, hope you can all hear me. Hey everyone, and welcome to episode 33 of Makercast. So, what is Makercast? It's a monthly stream that wanders from maker to maker, where makers share their latest projects. We always try and have some new people on, and they're going to talk about what they've been doing. So, what's the first rule of Makercast? Please tell everyone about it. It's really important that we get as many people on the stream as possible. So this week we've got some really exciting guests. We've got James Sharman. James has been building a 8-bit pipeline CPU, and most recently he's been adding VGA to it. So he's building all of that from scratch, so that's pretty exciting. We've got Brian Lough. He knows everything there is to know about Arduino and ESP. He's also an expert on robotic lawnmowers. We have bitluni. He's a full-time YouTuber creating elaborate and funny tutorial videos about building gadgets. He guarantees nerdy entertainment. And finally, we've got the unexpected maker, Sean. His mission is to inspire you to make something unexpected. He also sells the world's smallest fully featured ESP32 development board, the Tiny Pico. So check out their links in the channel description, and please subscribe to them. And of course, there's your host for tonight, me, also known as Atomic14. So I think James kindly volunteered to go first. So James, why don't you kick off the show with your segment?
Hello. Okay, so as Chris kindly said, I've been spending the last couple of years building a pipeline CPU, 8-bit from first principles. So it's all made from discrete logic. And if I find the right button and the YouTube fate smiles on me, I can show it to you. Right, stick me in the corner. Right, so the big chunk of PCBs in the middle is the actual CPU itself. On the right, you've got the pipeline, and at the top, you've got the ALU, and on the left, you've got all the registers and the memory. And it's kind of cool from a development perspective, because if you've ever done any kind of assembly language programming, you're used to talking about registers as kind of these ethereal things which just kind of store data, whereas here, it's a PCB in its own right. Now, I've got a whole set of side products on this as well. Now, on the top right, the green PCB, and I'm going to knock stuff if I lean all the way over to it. There's a UART, which means I can talk to the device over serial. On the left here is a VGA device I've been building. And on the bottom at the right is an audio device. Now, I've shown some of this on past Makercasts, but I've been making some good progress all along. And in the back, you can see an image with a craftily put together Makercast logo, which is displaying on the VGA device. Now, I'm a few videos into that as a series, so that's what I'm most inclined to talk about at the moment. But this is all built up from TTL and some memory chips. I've got sync generation. I've got some XY location and some RAM to hold the frame buffer. And the most recent thing I've added is some registers to handle hardware scrolling. So I'm going to give you a few little demos of that and talk about how that works. Now, last time I was on Makercast, you'll have noticed me unplugging ROM chips from here to plug new ones in. But one of the big new bits of functionality I've got is a loader program, which allows me to do that remotely. So I'll just give you a quick look at that. So here I'm just instructing it to take a block of binary data from the console, which is the easiest way to get some code in. And then I can tell it to execute that. So this is the first big side-scrolling demo I put together. So this has left to right and up-down scrolling, and it's got a little bit of procedural generation of this kind of tunnel and a little bit of shadow casting in there. So you can kind of see that will make quite an interesting starting point for a game at some point in the future. I've got quite a speedy processor. I'm quite proud of how fast it's going. I've got it clocked at 3.14 megahertz at the moment, which does mean I can do some quite interesting stuff because I can kind of monitor the synchronization signals on the VJ circuit and start to kind of tweak stuff. That's what people call beam racing. So that was the last big video I put out is on that. And that kind of leads itself to some more interesting demos. So I'll see if I can get some of those running.
While you're doing that, can I just comment on how you just said three megahertz, like really fast, 3 megahertz. Like, I mean, yes, super fast for what you've built, but like, yeah, I think we've moved on from
the thing is, what we're dealing with here is something that very much lives in the 8-bit land from the kind of 70s and the 80s. It's like you standalone TTL logic chips. There's AND gates, OR gates, NOR gates on there. And that's actually a pretty respectable speed for that kind of generation of hardware. Once you make your transistors kind of nanometers in size and pack them onto a tiny little silicon die, you can clock things a lot faster. But I'm pleased this does what it does.
So will you be spinning up a fab plant at some point?
Unlikely. Right. So what this is doing is this kind of almost looks like a 3D effect. Now, bitluni, I know, was very involved in the demo scene, so he's probably got an idea of what I'm doing here already. But what I'm basically doing is modifying the scrolling registers, but on a per scanline basis, so I can take out sections of the image and display them. And if I stop this program, what you see is it just goes back to the static parrot, because to have that effect going, I need constant monitoring and updating of the registers.
So do you have like interrupts for the horizontal retrace, or
no? It's all polled.
You just count.
I just count. Interrupts are basically cheating, bitluni.
Yeah, but they are available at the x86 architecture, as far as I remember correctly. So you could even like build this in and make it quite easy to like compute stuff in between.
Well, interrupts are actually one of those things where I did think about putting them into this build, but I didn't really need it for any of the stuff I was going to do. And because rather than a kind of a basic stepped processor, it's a pipeline processor, so I can get close to 1 instruction per cycle. But the pipeline state makes interrupt handling a bit more complex. So it was a kind of, I do one or do the other, but if I do both, then suddenly these PCBs get twice the size. So here's another scrolling demo, which is, it doesn't actually use any fundamental technology that I haven't shown in the previous ones, but it looks quite flash and parallax. So what I'm basically doing here is just horizontal scrolling different scan lines at different speeds and getting this nice, beautiful 3D effect from it.
That looks awesome. That looks really, really good.
Yeah, pretty impressive. Reminds me of the old games I used to play on my Spectrum and stuff, the parallax scrolling.
Yeah, I mean, it's obviously later on when you kind of hit the 16-bit era and people had things like the copper lists on the Amiga, effects like this were being done very smooth and very easily, because you didn't need that the constant attention of the registers. But in terms of the actual total overall circuitry I've got here, I mean, the VJ circuit there is kind of less than 20 chips, and they're mostly discrete logic. So this is something I'm quite pleased to have got out of it. Whereas this was the final biggest demo I put out in my last video. So this is kind of trying to look a bit like the old racing games on the Atari or
Lotus.
Pit Stop or something.
Yeah.
Outrun.
So
is that the one? Outrun? Vague memories of Outrun.
Yeah, that was 16-bit era, I think. But yeah,
the tricks here were kind of developed over the years. Once I've got a bit more resolution in there, at the moment my display is 80 by 60, which you'll recognize the kind of 8 pixel divisor from the basic 640 by 480 VGA. So I'm actually planning that that's going to be the resolution of my tile map. But it was quite an interesting step on the development to basically build what amounts to the tile set and use that as the pixel color, because that meant I could get the VGA circuit up and running with a fraction of the circuitry. So I'll add the tile data in a future video after I converted some of this to PCBs to save desk space. And that will suddenly mean I can actually drive far higher like visual resolution. And I'm going to add sprites and a palette system. So once again, there's actually a whole bunch of interesting beam race type effects I can do once I've got sprites and a palette system that will really make me able to do some visually impressive stuff.
James, you need to, sorry about this, mate. You need to add your nice ease in and ease out.
That was done in a hurry. It's not actually supposed to be a racing game. And what you basically have there is a whole little set of pre-cooked tables that I threw together from scripts that just get kind of blended together to create the effect. But it does prove that the visual capability is there.
Do you have sound effects as well, James? Have you built an audio chip?
Well, when you say audio chip, this over here is an audio device. That's currently basically got 2 channels on there at the moment. I'm planning on switching to 4 channels when I convert it to PCBs, which is actually one of the things that's going to come fairly soon. But obviously, 2 channels prove the systems, and then for 4 channels, it's a lot easier to copy paste stuff in EDA or replicate PCBs than it is to try and double up all the breadboards.
It's pretty amazing. I would amaze you actually that it still works and it's not kind of fallen over at any point. Because if I built something like that, most of my stuff lasts about a day, and then it's in a box, and trying to bring it back to life is impossible. Do you keep it fully assembled all the time, or do you take it apart and pack it away?
Well, I used to, right at the start of the build, I used to have it on my straight desk in front of me, and I would move it manually off to one side between build sessions. And then it got a bit bigger, and I had this piece of wood that I would slide it onto. And then after a while, it's like, no, it's just going to, and then you'll see a certain number of videos into my series, you'll see it just start staying on the wood, because then I could just lift it up and move it over. And then I've actually started keeping it. I put it on my main desk when I'm recording YouTube videos, but I take it and leave it there a lot of the time, because what you've seen is that I can do an awful lot of development now without actually having to touch it. And you do chunks of building circuitry and then a whole lot of software development now, because it's really kind of changed the phase of development on the system. So I build a small piece of circuitry, and then I have to spend a whole bunch of evenings writing code for it to actually drive it properly and see what I can do. And I can do that without physically touching the device, unless I put it into a broken state, in which case I have to lean over and hit the reset button.
Very cool. Brilliant.
So just quickly, I know that like all the stuff that you're showing right now is manipulation, like video manipulation, right? Like screen tricks. So I don't mean to belittle it. Sorry, shouldn't have said tricks. My point.
Tricks is absolutely fine. Everything you've seen here is, I mean, a stream like this doesn't do it justice. It's 60 frames per second and it's totally smooth.
Right. What I was going to say was, I don't recall ever, like I owned a lot of home computers and PCs, and I was very into the graphics and game scene in the 8-bit era. And I don't recall ever owning anything that had such smooth and colorful graphics in the 8-bit era, right? Like, I think that a lot of how cool this stuff is for you is because we're so far beyond the 8-bit era that we know now how to do amazing stuff with 8-bit hardware. Where back then,
Yeah,
maybe
no, there is a little bit of in hindsight, I can draw on all the tricks that game developers and demo coders have put together over the years.
Right. Yeah,
and there's also there's a couple of very specific things, like some of the demos I showed you can be done purely with scanline modification of the horizontal scroll register, and some of them require scanline modification of the vertical scroll register. And a lot of 8-bit era systems, and indeed later stuff, wouldn't allow you to modify a vertical scrolling on a scanline basis because it only reads it in during the vertical retrace. In fact, the first version of my VJ circuit suffered from exactly that problem. It's the obvious way to do it. So I actually had a video in which I stopped halfway through and added a small piece of circuitry up here that allows me to update that register, because there's been plenty of times when I was developing code, way back in the 8-bit era, or messing around on early PCs and a few 16-bit systems, where it's like, oh, if only it let me do this. Yeah. But of course, I don't have that kind of restriction.
Yeah, it's very cool. Well done, mate. Really good.
Yeah, so the sound, I haven't got that in a demoable position today, but it's not really advanced more than when I last showed it on a Makercast ages ago. I was going to show it the controller, but oh, there it is.
Hey, Jane, just quickly. So, Do It in the chat has said that what you've done, like, what's the motivation for for everything you're doing? Like, he's impressed, but there must be some underlying desire for.
This is about understanding. I have been a programmer. I'm not an electronics expert. I was never an electronics expert. I've been a programmer all my life. I've done a lot of low-level programming for particularly games optimization. A lot of the game systems that you may have seen over the last 25 years, I've developed games for. And you kind of, along that process, you develop a respect and an interest in what must be going on under the hood. So that's why this is a pipeline CPU, because particularly once Intel started coming along and putting a lot of very interesting rules into the instruction set for what would cause instructions to execute faster or stall them out. And then when I got into console programming a little bit further into my career, particularly some of the early devices like PS2 that were really, really blatant about how their pipelines were structured and how you had to drive them to get the peak performance out of it, you developed a really strong instinct for what was going on and a kind of a desire to know how it actually worked at the low level. And making like a 32-bit pipeline processor with all the LEDs and stuff is a bit of a big ask. But so in some ways, this processor is it's taking some of those later concepts that came along with early RISC systems, but I'm just building an 8-bit CPU with it to experiment with the ideas and also demonstrate them. And there's a lot of people who are commenting on the videos or joining in on the Discord who are building stuff themselves as well. It's a great little community, and there seems to be a lot of interest in this kind of stuff out there from at least this tiny little corner of the internet.
Yeah, we've got quite a few questions for you, actually. So what was your first computer, is someone wants to know. And then another question is, how many hours have you spent on this so far? So what's the total build time so far? So what was your first computer? Let's do that one first.
The first computer I actually owned, insofar as having complete access to, was a Sinclair Spectrum. Mm-hmm. There was when I was in junior school, I had access to a ZX81 at school. And my father was involved with the early stages of computerization in his company. And so he would frequently bring home computers and let me play with them over the weekend. So stuff like Apple IIs. that kind of era of stuff I did get a chance to play with a little bit, but not dig into in depth.
Great. And how many hours do you think you've spent? Or someone suggested maybe years as a...
Well, the stuff you see here is represented by, what is it, about 120 videos on YouTube. I probably don't want to acknowledge the answer to that question. If it was available to me.
I think they say every video takes like an hour, or every minute of video takes like an hour of work. So you can work it out from there.
Yeah.
I don't think that holds true for development projects though, because like
suffice it to say, James has spent way more time making videos than he has making the CPU.
Well, it's amazing. That is pretty impressive. Thanks, James. That's wonderful.
Yeah,
expensive CPU of all time.
The one little side project I've got coming up is ages ago. I built this, which is a NES controller, and I built the circuit to interface to it. And I'm in a few weeks' time, I'm actually going to wire that circuit into my CPU, so I can actually control stuff from a pad rather than a keyboard via the serial terminal.
Nice. So you built a games console, but it's the size of a table.
In many regards, yes. This is actually. I kept for ages saying I'm building a CPU, but in reality, I'm building all the components of a basic gaming system because that's what I do.
And then he's going to go into manufacturing and sell them.
Exactly. Yeah. You need to miniaturize it now. Shrink it down.
No.
I don't want the miniaturized version. I want the full thing. I want shift on a big wooden board, like the size of a door.
My plan is to, because I think the whole thing together will take up slightly less room than it currently consumes. And what I'm planning to do is put it all on, because it's all built from a module perspective. The next big job I've got is I've started PCB design work for the VJ device, and putting my hand over there is pointless because I've changed camera already. But I'm basically going to be putting that together one chunk at a time. So the circuitry I've got now will go onto PCB, and then that will free up breadboard space on the desk to put together the tile data and the sprite and the palette data.
Brilliant.
But I'm hoping to wall mount it eventually. Go up there or something.
Yeah.
But be functional on the wall.
Do you have any kind of hard storage like tape or some kind of, where do you store all the data right now?
Well, it's just got 64K of RAM at the moment.
Yeah, but how it's loaded? Is it like, do you have an EEPROM there, or how do you load the graphics?
Right. Well, I've got a EEPROM. I've got a ROM socket, so I can I can blow an EEPROM and put it on. But the only program that's on there at the moment is a monitor bootloader program. And so what I was doing in the gaps between demos was basically just copy pasting a text file into the console window, which basically writes the memory data in.
Really?
In order to
like that.
Yeah.
Assembled code, like.
Yeah. So I mean, I can show you this. If I switch back to that, so this here in the corner is my my monitor program. So I hit return there and break out the program because I've just got a tiny little function call I put in my main loops that checks for a return to break out of it. But I've got a whole stack of little commands in here, so you can see what that last program actually has in the frame buffer. I could do, for example, like the scroll registers are memory mapped, so I can go in and mess with them to move stuff about on the screen.
Oh, wow.
And obviously I could, in theory, put a program in this way. I don't have an assembler in the monitor. That would be going quite extreme. But what I do actually have an disassembler, so I can kind of dig into code. And normally, the only thing I really use this for is occasionally I go in and manually insert a breakpoint into a piece of code that I'm debugging.
What do you plan to add, like storage? What kind of storage would you love to have attached to it?
I want some kind of storage, and then I'd add support for it to the monitor program, so I can launch programs without having the PC attached. I'm not 100% settled on it. My kind of leading option at the moment is to implement SPI and then just use that as a MMC card reader or SD card reader.
Okay.
But I'd have to write.
No old school like tape device or anything.
No. I mean, the thing is, if you think, I did briefly consider putting a direct connection in for a Commodore 64 disk drive, because they're driven by UARTs, and I've got a UART sat right there that can do it. But I kind of I don't want to multi-purpose the serial port on this device, because I want to be able to always plug it into the PCB and play. So
with 3 megahertz, can you emulate a C64 that runs on 1 megahertz?
I feel like we're in Inception now. We need to go deeper.
6502. The simple programs I've coded and tested, comparing performance between 6502 and my processor, I'm significantly faster. How well that holds out on some bigger, broader programs is anyone's guess. But I would run out of memory. My code is less. My code is less dense than 6502. So despite 6502, a lot of stuff is kind of 2, 3, 4 cycles. All of my instructions are either 1 or 2 cycles, apart from a couple of very specific exceptions. And that's basically, if it's pure registers, it's 1 cycle. If it accesses memory, it's 2 cycles, because it takes over the memory subsystem, so that the fetch unit can't grab the next instruction. So it kind of defaults out to being 2 instructions. So I could write an emulator. I think the margin would be way off that. The only way to get that kind of performance differential is with a JIT assembler conversion, and because my assembly instructions, they take more space than the 6502 to do the same thing.
Okay.
It's just not going to work very well.
No, but it's still pretty amazing. I mean, that's good job. When do you think you'll finish?
Finish?
Right. There will be a finish. There will be a completion. There will be it's done. There have been a few points when I could have just overcommitted to adding stuff to it that would have meant it probably never finished. So I've been very strict with myself in building a list of stuff I'm going to do in the next build, the backlog list, as opposed to adding stuff to this.
I have a prediction of when James is going to finish. It's going to be the day.
Before you make a prediction, I will tell you the one concrete piece of information I have is when I started this thing 2 years ago, I estimated 6 months.
Okay. So my prediction
Still a good guess.
You're going to stop the moment you plug another PCB in, and the whole thing goes, and it all turns into magic smoke, and then you're going to stop.
Right. A few weeks ago, because there were comments earlier about stability, and when particularly the pipeline and the ALU were still breadboards, there were times when I would sit down and I would be poking wires in to find the loose one for half an hour before every time before I could start working on it. Whereas once the core CPU circuits hit PCB, I've had no problems apart from one day I sat down and the demos I had written the night before weren't running anymore. And eventually I found that one of these PCBs had just been nudged, and I just kind of put my fingers on top, and it clicked back into space. It was all working again. And yeah, that was quite a big sigh of relief.
I can imagine, yeah.
One question.
One more question?
About VGA, maybe I missed it. Does it work with palettes? So, or do you do like
a palette is planned at the moment?
Okay, yeah.
But basically, I've currently got a frame buffer which is 80 by 60.
Yeah.
But the plan is that that's going to be, and each of those 1 byte quantities go into a 332 DAC resistor ladder. But the plan is for actually those 8x8 pixel blocks to actually be a tile selection.
Yeah.
But if you see the logic of just building that and using the 8 bits directly as color data to get the VJ circuit up and running quickly, even though I can scroll it on a sub pixel, but what will be a pixel basis. And then, so I'll add the tile system, and then I'll add the DACs and a palette.
Cool.
So I'll have a 256 entry palette with, hopefully 24 bits per pixel.
Yeah, then you can you can do palette scrolling like animation.
Absolutely.
Yeah. It's fantastic. Well, that is one hell of a project. That's really impressive. So right, I think
I will finish one day.
You'll finish one day. Yeah, maybe.
I've banded around a 6-month figure from now.
Okay.
Which is kind of funny when you realize I said 6 months from the start at the beginning, but I was woefully unprepared for how much effort it was going to be, as is always the case with my personal projects.
Yeah. It's always going to be 6 months from now. That's the deadline. Brilliant. So, Brian, you're up next. Are you ready to start your segment of the show?
Sure. Why not? Something isn't working, but it's fine. I can explain it away.
What are all those boxes?
What are the boxes? Yeah. Are you moving house?
I moved house recently.
March
2020. March 2020 is when I moved. So that was recently, right? I'm doing up what should be my office. So a lot of stuff has been moved around, and it is right there. And I'm in the middle of other stuff that I'll get into that is taking up a lot of space too. Right. First thing we'll talk about is I got some pink PCBs recently. Let me move my dumb head out of the way.
Pink
PCBs. I got these off PCB Buy. They're kind of expensive, but not that expensive, I suppose. I think they're about. They don't have a fixed price for like a size like say JLC do, but I think actually. Are you sponsored by PCBWay? PCBWay also great. Just want to throw that out there. They don't have a fixed price. So like it varies per size. So I think it was roughly like $30 per design, which is fine. Looks pretty cool. It's a pink PCB. It's not very opaque, so it's kind of like white solder mask. So there is a copper fill there that you just can't see. Basically, you can kind of see it depending on how I shine the board. So yeah, it's kind of hard to see. Other than that, it's pink. I don't know what you want me to say. Here's a pink LED on a pink PCB. Brilliant. Okay, pink. Done. Let's move on from pink. Yeah, so next thing, the thing that has been occupying all my time for the last 2 months at least, and time before that, is I have received my ESP32 Trinity boards from Makerfabs, and yeah, they look pretty good. So this is a board for controlling those RGB matrix boards, one like this. which kind of doesn't fit on my screen. But yeah, so this is 64 by 64 RGB LEDs. So they're not individually addressable in the way a NeoPixel are, but they are individually addressable because of the shift registers on the back here. And yeah, the Trinity just drops into the input port, and then you use the power wires here and plug that in. I'll actually show a demo of setting it up now in a second, because it also shows something else I want to show. And yeah, that's it. It's assembled and it's ready to go. Has the ESP32 built into it. So I'm kind of excited about that. It's the next step on from, like, I was making these matrix shields and selling them on Tindy. They'd have an ESP32 that sits into the top of them. But the quality of these ESP32s is not the best. So yeah, I kind of wanted to make a version that is soldered, ready to go, and yeah, should work. And it has a couple of other fancy features too, such as it is now USB-C, which the other one wasn't, and can be powered using USB-C. It has a polyfuse on it to like limit the current that the USB-C will supply, but that's okay.
Does it have power delivery?
No, it does not. It just has, well,
Okay,
the
then
matrix
I make
board.
one with power delivery now.
You're welcome to do that. The matrix boards require 5 volts, so I don't think it makes sense to. Yeah, I suppose you could try do power delivery and get something higher and then buck it down or whatever to 5 volts, but I don't think it really makes sense. So this is a project I'm sure I've shown before, but I'm going to show it again. I'll move that out of the way so it's not an ad. Yeah, so this is my this is the RGB matrix panel. Here is my phone and Spotify. I'm not going to play any music, so Chris doesn't get you know, copyright striked. But I'm just after playing a song there now, and with any luck, in a couple of seconds. Yeah, so it's too bright, but can I adjust that on the fly? Go the other way. If I make it too dark, then it will start going crazy. So I'll just leave it where it is. That's not too bad. Yeah, so what it's doing is it's connected to my Spotify account, and it's grabbing the song of what is currently playing on Spotify and downloads the album art from that. So if I throw on something else here, I don't know, Songs for the Deaf actually has a nice thing that'll probably look okay on a 64 by 64 matrix. It's not the fastest because there's a 5-second poll interval that I could make smaller. So there's a 5-second poll interval, and then it needs to download the image and display the image. So it isn't the fastest, but it should update now in a few seconds. You could get a little bit smarter about it too, in terms of like if it's just moving from song to song on your playlist, that like is in it knows when the song is going to end, so it'll you know, work off that. So it looks better in person. It doesn't look quite as white as this. It looks more red. So yeah, so that's nice. The thing that's broken about it is the best feature about this project, and it's working absolutely fine on the one downstairs. My kids use it literally every day, but I have these NFC tags, and this little PCB, there's actually 2 of them because I was testing out I2C and SPI versions of it. So what I do is I write the URL of the song to the NFC tag, and on the ESP I parse out from that URL. There's a Spotify URI, they call it, and the API uses the URI to change songs. So I have a song written to this, and when I tap it off this, it'll tell my phone to start playing the song that's on it. So we'll do that. But the problem is it's crashing the ESP at the moment afterwards. So it changes the song and then crashes. So it's like, let me do this one last job for you, and then I will die. So it has that blue and red symbol around it to indicate that it has read the tag. So yes, you see it restarted, and it didn't update the song this time. Sad times. So let's try one more time.
Live demos, mate.
Live demos never works.
I'm convinced.
Yeah.
Where can I buy it?
Yeah, we'll get that working some other time. Yeah, that's disappointing. It was at least updating. I did make code changes before this to try to fix it, but obviously I made it even worse. So that's fine. But it does do that. I promise. Okay, so that's my NFC Spotify project. I will be it is on GitHub now if anybody wants it, but I'll properly be releasing a fixed version of it at some stage. Yeah, so the next thing that I want to show is it's continuing the infomercial of the Trinity, but it's actually something that I've been working on that's really cool. It uses the ESP web flash tools. So let me show you. If people are familiar with my channel, I made a Wi-Fi Tetris clock before, where like it's a clock that fetches its time from the internet and like draws the time using falling Tetris blocks. And it's a pretty nice project, but it has like a lot of dependencies and things. Like you need to install the matrix libraries. You need to install like the Adafruit GFX, the thing for getting the time, the Tetris draw project. So yeah, I want to show this how web flash tools could make sharing it really easy. So with the Trinity, you just plug it in here. You take this thing. This is a wire that comes with the matrix panel, and you would just throw it in here. So if anybody has any questions while I'm making this up, but it'll literally only take a second here.
So when's the Trinity board going to be available on Tindy? When will you be selling it?
Next week, I would say. Probably next Saturday, I would think.
One question from my side. Can you add some touch buttons to the Trinity in the next version?
There's touch buttons on this version.
Wow!
There's 2 touch buttons there, which is one of the added features over the I2S shields. Yeah.
I'm sold now.
One of the other added features is pink LEDs, 2 of them. One of them being user controlled and the other being like the power LED. Right, so that's it plugged in. This is just USB from my computer and that's it. And it's hooked up to the matrix. It's actually displaying something now, but we won't worry about that. What we're going to do is go to my LG monitor share. So this is my this is a web page that I'm hosting using GitHub Pages, which is a nice way of getting a simple like web server that has HTTPS built in for free, basically. And what I've done here is I have a compiled binary of the Wi-Fi Tetris clock project up on this website that like anybody can visit. I have my ESP32 plugged in via USB. The only piece of software I need installed on my computer is the driver for the USB to UART chip. So in this case, it's the CH340G. But yeah, so hopefully this works now. So I'm going to click install. I get the options. It's probably a bit small for you, but I get basically my 2 COM port options. So I know it's COM port 5. I click connect, it does initializing, and it should, so it's now writing the binaries for the project onto the board. And yeah, it'll take a couple of seconds or whatever, but yeah, what's super cool about this is like I don't even need to have the Arduino IDE installed, never mind the ESP32 board devs or any of the libraries, and I'm able to like get this up and running. So it's a really nice way to share a project, like especially if there's kind of like a complex like install path for it, like if you've tons of dependent libraries, or sometimes you might even need to make a modification to one of the dependent libraries. I think this is developed by the ESP Home guys. Like when you're installing Tasmota or ESP Home, like this is probably a good thing. WLED also definitely supports it as well. So that's it. That's it done. It should be kicking into Wi-Fi Manager at the moment, but I already had this project set up on this already. We've probably all seen Wi-Fi Manager anyway, so it just makes a captive portal for you to configure like the Wi-Fi settings and things like that. Because it's a binary I have put up on it, like it needs to be completely generic for everybody. So like things like putting in your Wi-Fi details, setting the correct time zone, and some of the other matrix config options as well can be done through the captive portal. And so that is this, which is pretty nice. Like, is in literally, I don't know how long I was talking for, maybe 6 or 7 minutes. I went from like a blank Trinity, for want of a better word, I had other stuff on it, to like the project finished, which is quite cool.
It requires Chrome, doesn't it? Browser?
It does require Chrome, yeah, because Chrome is one of the only browsers that supports that USB serial stuff. Yeah, so if there's any other browser that starts supporting it, that would be fine. But yes, it does require Chrome for now.
Genuine question. How does it detect what kind of matrix this is? This is like a 64 by 32. Do you have like dip switches or?
No, it doesn't do that. That is, so let me enter config mode and I'll show you here. So what I did there was I double pressed reset. So pressing the reset button twice to force me into config mode. It's just a nice way of like freeing up a button. Like I could have mapped it to a touch button or something, but that I might want to use them for something else later. While the reset button for a thing like this, which is, on startup, you either want to enter config mode or you don't. A double reset detect is really useful. Basically, it like writes to some memory, or persistent memory, and after 10 seconds, or it's configurable, but after 10 seconds, it will like remove that flag from persistent memory. And then on the next startup, it checks that for that flag. And if it finds it, it goes, okay, yeah, they've pressed reset twice in the last 10 seconds. I need to enter config mode. So I wish I had a better way of sharing this now than showing my phone. But anyways, so configure Wi-Fi. Let's press configure Wi-Fi better. Oh, I've disconnected from the Wi-Fi. Oh, it's back. Yeah, so you can enter in your SSID details and stuff like that. And then I actually have the option in here so if you had plugged this into a 64 by 64 panel, you could get it to work in that too. So thank you, bitluni. you got me back. Pretty about the times I've done it to you. So that is the Wi-Fi Tetris project. The other thing that I've been up to, but I don't really have anything to show for it yet, is my home heating controller or timer was broken, and I swapped that out for a Sonoff. So I am starting into the world of like home assistant and that type of thing. And yeah, I think it'll be fun. Once I don't kill myself wiring the Sonoffs and stuff. But the Sonoff is in and working fine. I've done something with the sun off that I don't believe anybody else has ever done. I have left the default firmware on it. Most people just install Tasmodo straight away, and I will, but yeah, that's pretty much it for me. Yeah, as I mentioned, Trinity has been absolutely chewing up my time. Yeah, it's interesting, but hopefully next week will be released. There is like a good few in one of those boxes behind me, and yeah, so it'll be fun. I sent out a couple of samples to some big time YouTubers as well, so we'll see if they get them.
None of us.
Yep.
Yeah. Just
definitely not us.
Whoever wants one can ask me very nicely, and I will probably say yes. So, yeah. So yeah, that's pretty much it from me, I think.
Brilliant. Cheers, Brian. That's great. So I think bitluni, you said you'd go next. So you're it. Are you ready?
Yeah, I hope so. So, since last time I was on the Makercast, I started doing like weekly streaming. I don't like when like YouTubers do only streaming, like I do now, like it looks. But it's a way for me to be more productive on that side, and I'm really about to make like real videos from the project that we did there. So we had like one theme that was suggested by my viewers to do like a 1-day challenge that I do on a single stream. The people suggest and vote on the project that is done. And we did like 2-3 installments already, and the first one is the one that I will present because the other ones already broke. Like this is the accident counter that yeah, I have unfortunately I have like detached 2 wires. It was like it was too stiff, but basically whenever I hurt myself, I can press the button. There was a Wilhelm scream, and it was printing on one of the thermal printers. Like
that I found. I just want to throw that out there. He stole it from me.
Yes, Brian found.
I didn't find the meter. I stole it from Larry.
Larry,
but I stole it from him first.
Yeah, you stole Larry. Basically, I can find the other ones. This is a Perry page. That's like they're simply like cute little printers with a roll in there, and they work with Bluetooth more or less. You can. Sorry?
Is that thermal, the printer?
Yes, yeah. Thermal printer, yeah. And they work with Bluetooth low energy, I think, even. And Larry did an Arduino library to access one of the printers, and he even extended it to the other printers as well. I can't find the other 2. It must be somewhere here.
I can show them if you want, bitluni, seeing as I was the first person to get them.
Yeah, show them on. Where is it? That's a mess here. Oh yeah, that's the one. That's the easiest to access. So, and yeah, Brian, you are muted.
Yeah, that was the Go JPRT. That was the original one. You showed the Perry page one, right? That's the bear one, and then there's
the cat printer.
I'm not sure if I got the cat printer. No, I did. Yeah, of course I did. Why did I get a cat printer? No idea.
Yeah, and the cat printer is a little bit harder to program since it has some like checksum and stuff, and also the latest implementation of the Bluetooth stack on the ESP32 crashes sometimes there, but that's an ongoing project. Then we had like something that a super basic one, because all of the time when I'm working on other stuff like away from the screen and the people are screaming in the chat and I can't read it. We had like a basic piezo buzzer connected to this ESP that was controlled by chat with exclamation mark fail, and it would set off a beep. And we had even text to speech on over Node-RED. That was quite enjoyable because the people sent, of course, hacked it and sent images and so on and so forth. But the first one was the longest stream. I will switch my camera if it's still working here. Yes, it's working. Okay, so I got from a viewer, I got this flip dot matrix, and the first project was, oh yes, Brian is doxing me as well. The first project was to like control this, and I didn't knew what I'm doing. The viewer sent me also the ICs that are like drivers and shift registers. I have a few here, and it took us like 15 hours on stream to set this up. We only had drivers for half the display, but after 15 hours so the task was to, maybe I will show it. Okay, so that's, whoa, not
broken.
I hope not. I hope it's still working. Yeah, it's still working. So I'm printing a proper case right now as we speak, but it takes quite some hours because it's quite a huge display. Yeah, that's like an flip dot oscilloscope, and it's in the roll mode. I can maybe demonstrate it before I break it. So let me connect it to my other oscilloscope which has a wave generator. That's like a sine wave. I can set the frequency. That's like a low frequency. Let me set it to a higher frequency. So, yeah. So it actually works. And we got it on after 15 hours of stream. We got it like it was only the half the display, and it was rotated by 90 degrees. And we got it working. And it actually, this update is a little bit slow because this display, I will turn it off for now. Yeah, it's moving out. This display has only like not a complete full like H bridge per pixel. It has like the reset only works like column wise. So you either reset the complete column and you can set each pixel individually. So it takes a little bit longer to update a complete display, or if you change only a few pixels, you might need to update a complete column at once if the pixel changes in a different way. And what I did later, so the stream was 15 hours long, people went to bed and got up and joined the stream again at work and so on. And yeah, we even like used things on this one that weren't like supposed to be used. Like this is like PWM and like PWM extension shields, and we use them basically as shift register like supplements or whatever. And yeah, after that, when I get the focus back, I can turn. I will just unplug it live. It will be terrible. I probably break the board now because my power supply is on the other side of the room. I designed yeah, that was another live stream where I told people to show me how KiCad works, and this is basically my first board that I designed with KiCad because my new sponsor, which is Isla, where I got the boards from, they have a like, if you upload like the project, you don't need to export Gerbers and so on. And yeah, I tested them and got like this is the board. It's called the bitluni's Flippy Flip, and it has like some yeah, the design decisions are not the best, but it works with only one teeny tiny botch, and it has also a pink LED. Pink in this case, it's like more of magenta, I would say. I don't know if you can see it, and it even says, if we get some focus, it even has a label that says only pink, and you can't do anything about this LED. It's just like a power LED.
It's more purple. It's good though.
And I had to screw on this huge heatsink because this board is powered by 24 volts, and I'm just using a basic 5-volt voltage regulator to get the power for all the ICs, which are not. These are like high side drivers, and we have some low side shift registers and some additional shift registers to address the high side drivers. So it's like the board is not very efficiently. I guess there are probably some high side drivers with shift registers included, but I don't know anything about that. So I designed it like I just thought, and yeah, it's working with the ESP32 mini board, and I added like the probe, the oscilloscope probe. So I made this board with the first project in mind to make it like that. I didn't even bother order the right connector for the flip dot display, and just cut off like female not pin headers or the sockets, and that's about it. So this is quite hot. It's getting really okay. Now it's warm to the touch because the ESP32 it draws so much current, and if I would like, I'm not using Wi-Fi now, and I think that's about like 500 milliamps, and you can imagine if you use 24 volts to like 5 volts, and you have 20 times like 10 watts of heat is wasted here because of the ESP alone. So maybe a step down converter would be more efficient, but it's like too many components. I just wanted one component there, and that's about it.
There's a guy, Ketan, who used to be around on my Discord. I haven't seen him too often recently, but he made a buck converter, the form, like the size format of the LDOs, just for such an occasion like this. Like, just a good drop it into a single component. Maybe if he has it, I think it's open source, so maybe.
Yeah, if you can drop a link, that would be cool. Yeah, and that's about it. It's not very complicated board, and yeah, there is also like the bitluni features, like the GND label is a little bit tilted to trigger all the people, and I even had some spare half bridges here that are basically screw terminals, so I could even drive a motor here with that, and there are some spare like pins even for audio or whatever. So yeah, I'm hoping to use that. This is very specifically for this design of flip dot matrix, so probably nobody will ever use it except for the guy that sent me the flip dot, because he has another 2 of these, and you can't buy them really. So you have to be really lucky on eBay to get one. I will just plug it in. Oh, plug it live, still working. That's cool. Very very robust design by bitluni. Yeah, and yeah, I hope to use this. I'm printing currently like a basic 3D printed case where I can put it on the wall and maybe use it for different displays, like the accident counter that displays how many seconds since the last accident in my lab happened, and maybe people can like put something on the scroller from the chat or whatever. Yeah, that's everything that I would like to show, I think. Yeah.
Pretty
Let
cool.
me change the camera.
Very nice, bitluni. Brilliant.
Yeah.
Thanks.
Can we get a better look at the mess behind you?
Yeah,
Yep.
sure.
Where's your office?
Doesn't have anything on my mess.
Yeah, you'll notice I managed to crop
this
my
is the
screen to
key.
not show my office.
Maybe I can.
Yeah, that's the
rotate.
clean side.
Put on my mess that way.
Whoa.
What do you
that's
think
all
is that way for me?
What are those things in the background, bitluni? What's the
Yeah, that's the one, the
projectors.
project that people probably waiting for an update for, but that might take a while because I have so many things lined up. These are like the 6 VGA board. I showed that so many times already, so I don't bother. There is like a stack of the boards behind me there. So, and they are even working. That's like only the 3rd iteration.
That's a surprise in your voice, bitluni, that they're even working. Yeah.
Yeah, you know, I tend to flip things. Yeah.
Yeah.
Nice. All right. Sean, are you ready?
Yeah. Yeah.
Excellent.
I'm just going to.
Sean's up next, all the way from Australia. It's 6 a.m. or 7 a.m. now.
I'm so far away. I'm just going to quickly mute myself and turn my lights on so I don't trigger anyone else's home assistant. 1 second.
So,
Uh-oh.
Sorry, fire isn't responding.
Sorry, fire.
Hang on a second.
was that a live demo going wrong? So while Sean talks to himself, let's talk amongst ourselves.
Wow. Okay. Well, that's not working. I've got no lights in here. That's going to.
Fire isn't responding.
The internet of I won't say
Fire.
bad.
I can't set myself on fire on a stream. No way. Okay. Well, that's going to make things difficult. So, for those of you that caught my video the other day, I have been tinkering over the last little while collaboratively with Marius from Norway, not Netherlands. I got that bit wrong. Oh, well. We've been playing around with different ideas to do with, well, both of us have been working on the stencil printing problem. Or as in the solder paste application for stencil printing. So those of you that do any surface mount work that use stencils, whether you're using like non-framed stencils like this, or whether you're using frame stencils, whether you're even making your own stencils, etching them yourself, or using mylar, laser cutting them, whatever else, they all pretty much have an inherent problem in that how do you get the stencil to sit flat and still on your PCB while you're pasting? How do you get a really good paste application and don't have the paste squeeze underneath? How do you, I mean, a lot of people you'll see when they're pasting, they do multiple wipes and they wipe in different directions, which you really shouldn't do because you're just pushing paste under. How do you get the perfect paste? For me, it's about production. Like every time I have a board where the paste isn't perfect, I'm going to have rework after the board's been assembled and reflowed, and rework just takes so much time. So I'm all about how to improve that. And the easiest way is to go out and spend $40 or $50 or $150,000 on a really good fully automatic stencil printer that does it all for you. But I don't have that type of cash sitting around, and I don't have any space for one anyway. So I've got a manual stencil printer, one of those ones that kind of looks like a silkscreen printer that you can lift up. You put your PCB in, you pull it down, you align it, and then you paste. The problem is PCBs, especially if they're panelized, they come bowed and bent. mostly from packaging. But the fact is, if you've got a PCB and it's V-scored, for instance, you're introducing the ability for the PCB to flex. You have to mount it inside the stencil printer. You need to put the stencil down, and getting the stencil perfectly aligned, not from a position point of view, but from a height point of view, is, well, for me, it's fairly hard. I mean, I've got fairly good eyesight. Sure, I wear glasses, but I've got different types of pairs of glasses that, allow me to do really close-up work. And because of the pitch that I'm working on with a lot of my parts, the thickness of the stencil is only 0.1 millimeter thick, 100 microns. So if it's not sitting perfectly flat on the stencil, on the PCB, it could be out 50% of the thickness of the stencil. So if I want to only get paste that's 100 microns or 0.1 millimeter thick on the PCB, and it's sitting 30 or 40 microns high, I'm either going to get too much paste to go in and squish under, or it's not going to actually touch the PCB. And when I pull the stencil off, the paste comes back up, stays in the aperture because it hasn't actually touched the PCB properly, and I get pads with no paste on them. That is just, it's a nightmare. And there are so many factors that are involved with pasting, temperature and humidity at the time, how, whether your paste is old, whether it's drying out too much, whether you've taken it out of the fridge early enough and let it warmed up, whether you've mixed it enough. There's so many things that can go wrong with pasting. I'm trying to eliminate as many as possible. And Maris has also been doing the same thing. He's been playing around with making both a fully custom stencil printer, like an automated stencil printer, or semi-automatic, but one where it can automatically lift and lower the PCB to the stencil. He's playing around with framed and frameless ideas. But we've both been playing around recently with vacuum beds. And I started with the intention of working out how to make one for a CNC machine so I could do my own PCB routing for PCB separation. So I could take a panel of boards like this, like tiny picos that are already made, put them inside a CNC machine, and I can't just put inside a CNC right now and clamp it down and cut it because I've got no way of clamping the individual boards. So a vacuum bed that sucked the whole thing down would allow me to cut these out without the PCBs moving because of the vacuum. And Maris was playing around with that kind of same idea, but for manual stencils. And so I've evolved mine into a system for my stencil printer. Now, this is a newer version of what I showed on my video the other day. And it looks a bit funny with the the adapter on the side. So I did have the hose sticking out this way, but I wanted it to go back behind the unit. Unfortunately, it's got to go on an angle because the stencils are quite wide, and this section can't hit the stencil won't come down. But the whole idea is, if I just go to a previous version, the whole idea is these run off a vacuum cleaner, which is crazy, I know, but who doesn't have a vacuum cleaner? So you plug a vacuum cleaner into it and you turn the vacuum cleaner on and it sucks. Looks like a flux capacitor. Yeah, without all the flashy lights though. And it sucks air in and basically makes anything that goes to it stick to it. So I started playing around with a whole bunch of different ideas, and my first iteration was I wanted something to be modular. So I built this system where these individual pieces had holes in the top to suck air. You can see that there's a raised and lower section, so the PCB would sit inside. It's a bong. Yeah, it's a flute. And that what you could do is they just plug into each other, and you can make them as long or as short as you want. And oops. Anyway, yep, doesn't matter. There we go. And so the whole idea was it was modular, so that way I would not have to print custom tops for each type of panel I've got, because I've got, as of yesterday now, I've got 19 different stencils, frame stencils, sitting in my stencil area, and that means I've got probably all up about 12 different shape panels that I do production with that would mean I needed 12 custom things to go in the stencil machine, which is way too many. But the problem with this is it because of the nature of it, it just didn't work very well. I couldn't suck enough air through it. The openings joining it all together were just too small. So the next thing I did, I mean, what I should have done is gone straight to my idea now, which is, and what Maris is also doing is printing it in 2 sections. But I wanted to see if I could print the base in one go, as in this. Got a bit of a rattle because some support that was on the end here, as I was trying to get it out, I accidentally pushed it in and it's stuck in there now and I can't get it out. But anyway, this was printed in one piece. Now, I know it looks like there's a top on it. I actually ran out of filament, and it just so happened that the swap of filament, I ended up going to a different color, makes it look like there's 2 halves, but this is all one piece. And so this was a solid chunk of 3D printing, but what I did is I put, I can't remember, I think it was 160 spheres inside here, and I booleaned them out. And so the reason I used spheres is that gave a natural, like an arc or an arch inside that allowed the top to be supported. So I didn't have to, like, because obviously I couldn't just print the top, it would fall down, right, without supports underneath. So inside here are like 160 little arches that hold the top up but give like an open space inside, and it actually works really, really well. Unfortunately, I got the spacing of the holes on the bottom wrong, because I discovered that the alignment of the holes on my stencil printer are not symmetrical. They're not, or that it skews off as it goes up. And so it didn't screw down. So that was a 17-hour print that was a waste of time. And probably about 6 hours of designing this thing to make it hollow, to make it and not have the top fall in. It was a nice exercise. I'm glad I did it. I'll never ever do it again. And then
it's the worst thing about 3D printing, isn't it? It's the hours and hours until you find out it's wrong.
Right.
Really,
yes. And what I should have done is printed the bottom first to check it. And so I started doing that. So from then onwards, everything I printed, I would print the first layer or 2 layers of the print first, so I could measure it and put it down, right? And the same thing with my lattice design. I printed, in this case, it was 2 layers. I got distracted and I came back and it printed 2 layers. So I've moved on. So the version I had on the stream, so on my video, the problem was I couldn't clamp it down onto the bed because I designed it to put the screw holes. It wasn't working well. So what I did instead is I got rid of the holes on the bottom and I put these little tabs on the side, and then I printed some of these little adapter things and they clamp it down, and I use the normal M5 bolts on the bed that would normally get used to screw in the little mounts and pin holders. And that holds this down perfectly. So now I've got the thing stuck down, and I'm just going to, I'll leave that on for the moment. So there's the 2 halves here. There's a top and a bottom, and they're just screwed together at the moment. And then what I do is I print a custom plate. So this done in red, that holds my PCB. So the PCB just sits in there, right? And it just comes out. And each one of these is 3 millimeters high. And I inset, so these are 1 millimeter thickness PCBs. I just inset it the 1 millimeter with a little thing to flip it up. And what that allows me to do is, once it's in, is it gives me a perfectly flat area here where the PCB gets sucked down through the holes, and the raised section holds down the stencil. And so when I turn the vacuum cleaner on, it sucks the PCB perfectly flat. So even if there's a bow on the PCB, it gets completely flattened, and then it sucks the stencil directly onto the PCB. And even if the stencil is sitting there and it's not perfectly flat and it's not perfectly it's raised on the corner, it doesn't matter. It just gets sucked right down, and I get a perfectly flat surface. And it's like, my vacuum cleaner is probably overpowered from what I'm doing with at the moment, but it's incredible. Like, the thing can't move at all once the vacuum is sucked. And then I can paste, turn the vacuum off, and then the stencil comes up a little bit and I can lift the stencil and I get a perfectly pasted board. Now, a few people asked me on like in the comments on the video, what do I do about the like my USB connectors have got little peg holes, right? So there's paste in these little holes. Now I'll turn it around. There are a paste in these little holes here for the USB. And isn't that going to suck the paste through? Well, what I do is on the actual design for each of the stencils, you can see that there are holes missing and they align to where those peg legs are. So there is no way that those will get sucked through. And everything else is in a completely sealed vacuum. So no paste can move sideways. No paste can go anywhere other than onto the pads because the stencil is being sucked directly onto the PCB. Like it's like if I was going to get paste going sideways, I'd get it without the vacuum, and I don't get it without the vacuum. With the vacuum, yeah, it's incredible. So what I'm actually going to show you something. I'm going to have to mute my video when I do this because it's going to be loud. But I'm going to this stencil here. I'm going to do this live. I'm going to plug this into my vacuum cleaner and stick this stencil on and show you just how insane this thing is. So I'm going to mute.
Hopefully his live demo goes better than mine.
He's going to reappear covered in solder paste.
It's like a mime show.
Okay. So it's plugged in. It's connected. The vacuum cleaner's all over there. It's going to be loud, but I'm going to mute because I don't want everyone to have to listen to my vacuum cleaner.
I'll imitate the noise of a vacuum cleaner at a lower volume. He looks like Charlie Chaplin here. It was like, it's from that kind of era.
That's pretty impressive.
Look at this fall. It fell off. Oh, no, it didn't fall. It disconnected.
Okay. I should have figured that was going to fall off that. Okay.
But
anyway, the point is.
Okay, people want to hear the thing with sound. So can you do it?
Now.
Do it not muted.
Is it
I
broken?
want to hear it with the
Not muted?
Yeah.
Okay, I'll do it again, not muted. So, hang on. I knew that was going to fall off. I haven't glued the adapter onto this yet.
Oh yeah, that's in there.
So it's this that came off. That's all. I'm still playing around. I've got a whole bunch of different angle pieces. I'm trying to get the right angle for this piece here, so I don't want to glue it on yet, and that's what fell off. Okay, I'm going to turn the vacuum cleaner on again. It's going to be loud.
Oh, my ears.
Pretty impressive.
It doesn't move.
Yeah.
When it was on mute, it was more like a magic trick.
I'm wondering if you can use it as a back massager or something.
Okay. What?
Yeah, it's like
You
a
have like
massager,
this
isn't it?
suction cups on. There is like this therapy where they're putting like suction cups on the back.
Yeah.
So if you might want to sell it as a back massager or
No.
with
I'm
different
not going to sell this at all.
add-ons, you can maybe do different devices with flexible filament.
Looney is getting dangerously close to making this R-rated.
Oh.
Yeah, no. I'll be happy.
You do the suction caps for climbing walls and stuff.
Oh yeah.
Except you got to put the vacuum cleaner on your back while you're doing it.
And have mains power. That'd be really convenient.
Yeah,
What
that'd
you're
be
doing
great.
is cable gets all the way. Anyway, the point is, this solves, for me anyway, it solves so many problems because I've got PCBs that are 0.8 millimeter, 1 millimeter, 1.2 and 1.6 millimeter thick. And in the past, every time I put a different thickness PCB on, I had to readjust the height of my stencil printer. And adjusting it 0.2 of millimeter is impossible. Like there's no fidelity on these machines. And so I'd often my first or my second panel that I'd paste would be bad because I still had to keep tuning the stencil. And you don't want to wipe down, like for a lot of my boards, I can't just wipe down the panel and reuse it because you get paste inside vias and all sorts of other stuff and completely changes the board. So there was a little bit of wastage. But with this, each one of these is always 3 millimeters high and I inset into it. So I've got now a fixed height stencil. I never have to adjust the height of my stencil. And even if I take a stencil off and put a new one on and there's a little bit of tilt or something with it, the fact is the suction just sucks it down straight and it doesn't matter. I don't have to do any adjustments anymore. So I've been busily printing off all the different types of adapters I need. And yeah, it works much, much better than I was expecting. I'm quite surprised, but I do need to get a different vacuum cleaner that's got the ability to turn it down because this is too strong. I don't need it this strong or this loud.
A little Dyson battery powered one, then you can climb the walls again.
Yeah, I don't know if I want to do battery powered. I don't think it'll last very long. So, I mean, people were complaining about the noise in my video, like, you know, why do I have to use a loud? Can't the vacuum cleaner be in a different room? The fact is, like, you know, I'm using it for 30 seconds at a time. Who cares how loud it is, right? You know, when I'm pick and placing, the noise in my garage from the pick and place machine and from the compressor going and stuff is loud enough anyway. I don't care about the noise so much.
You've got your electronic dance music on while you're doing this, I'm sure.
That's
too.
right. I've
Anyways.
got my noise cancelling Bose headphones on, and I can't hear anything. It's great. So people were asking me if I'm going to open source this or not. Well, I'm not selling this as a product. Like I'm not 3D printing things for people. This is like 25 hours worth of printing here. But yeah,
I'll like a generator that generates like the plate where your PCB goes in, or do you like do it on the fly with your design tool, with your CAD tool?
It's all in Fusion. I haven't done it parametrically.
Yeah.
But what I've done instead, just to make sure that everything fits right, as you can see, this is like a really good, perfect fit for this panel, is I actually took my design of the board into Fusion and repanelized it in Fusion and then used that to cut out. What did Mike just write? Who's pasting? You could flick the vacuum in reverse and play SMD air hockey. Yeah. So Mike. So these top plates they're a little bit.
Oh shit!
What did you drop?
My display fell down. I was laughing too loud. It fell off. The people in the chat are hilarious today.
You put a pipe feed in from your compressor from the pin plate. Yeah, so doing vacuum from the compressor is not powerful enough. Using a Venturi type system or something else, you need, even though my vacuum cleaner is quite powerful, overpowered, it's still, 100 times more powerful than what you could get off a compressor. But you can actually buy vacuum pumps that are quieter, but they're $700. Like I don't have a problem with software vacuum cleaner. I don't care about the noise. Like it's only a problem if I'm.
A lot of the vacuum cleaners have like dials on them, anyways, don't they?
Yeah, little sliders to let air out.
Yeah.
Yeah. Well, that's the thing. I could get a release valve, right? But that's still not going to reduce the noise of the vacuum cleaner. This is a shot valve. It's one setting, very loud, very powerful. It's like 2,400 watt vacuum cleaner, right? Where a normal like household one is anywhere between 1,200 and 1,600 watts. So anyway, I can make it quiet if I need, but that's not my purpose.
I have a shop vac that has like a socket on it, right? That you plug your power tool into, and when you engage the power tool, like the current draw that's going through it is enough to tell the vacuum to turn on. So the vacuum only turns on when you engage the power tool. So you could like stick like a drill beneath your desk and be turning that on with your foot. Which would
right, so I'm holding the stencil and I've got the stencil here and I've got the drill with my
like maybe you fake it to something else, but like a foot pedal, like would be nice for this
Yeah,
solution.
or some
right?
bellows, and you could just. Oh, that's the wrong way, isn't it?
I can go.
Marius makes a good point somewhere. He's like, how
Oh,
do
yeah.
people vacuum their houses if they're complaining about the noise of a vacuum?
That's a good point. Yeah.
Yeah. So Random Hacks just asked me, and this is part of the problem, that every time I get boards from JLC PCB from my provider, PCB provider, they're different. Right?
Other providers are available.
Yeah. So like the panels, they're always different. They're always rather different. So this is my Tiny Pico USB-C. I had an order of so it's 100 panels, right? So 2,000 boards. Yeah. And in the one order of 100 panels, there were 3 different versions of where they drilled the pinholes. Now, the pinholes are in the design. They're in the drill file. If you download their Gerbers, they're in the actual design. Yet, 3 different places they put the holes. So I'd take a panel, I'd put it down, and it wouldn't fit. And I'd have to go and reset up my Stencil printer for the new pins. And then I'd go take another panel, and it wouldn't fit again, right? There's all different issues you get with different thicknesses of the boards and stuff. So relying on a perfect layout to place these in all the time is really hard. This suction solves all that. It doesn't matter, right? Because once it's sucked down in place, it doesn't move. I can push everything into the corner. The only problem I've got is when the suction's going, you can't adjust the stencil position, like you can't alter it because it's so strong that it won't move. And that's what the problem I was having in my video. So I actually had more footage that I had to cut out of the video because it was getting a bit long. But I was actually showing how I was adjusting it. And as I was adjusting it, it was because I couldn't clamp this base down. It was moving the base. And then I went to lift the stencil up and it actually lifted the whole thing. It was stuck to the stencil. It was like this. I'm looking and I couldn't find the base of the PCB. It was just gone. So that's why I had to put the clamping on. So anyway, it's really cool. It's exciting. Marius is also sharing stuff on Twitter. And I think he's going to be releasing some videos of the stuff he's working on. He's primarily focusing on non-framed. So he's adding things like little springs and stuff that lift the stencil off when it's not being sucked. I can't do stuff like that because I need the stencil down all the time to be able to align it. So we've got some pretty cool ideas. We've been discussing things like magnets and using powered coils to turn the magnets on and off. There are a lot of different options for stuff like this, but I'm quite surprised how many people got excited by the video, like other makers and stuff that want to start just playing around with vacuum stuff. Like it's a really clever idea just to use a vacuum cleaner, at least for experimenting and stuff. If I can get this system running perfectly, I could always go out there and buy, spend $600 and get a really good vacuum pump that is considerably quieter that can sit outside in the garage or something. But for now, it's all about getting a little bit tasting. So
I love that concept of like using a cheap, like something that is widely available to like do some, like a specific job like this. Like vacuum cleaners are like by far the cheapest source of vacuums you can get. Like, and why not make use of it?
It's a DIY thing, right? I mean, who doesn't have a vacuum cleaner or have access to a vacuum cleaner? I know not everyone's got access to a 3D printer, but that's becoming more and more prevalent now.
And you can buy prints off PCB, where the sponsor of this channel.
Absolutely. Or somewhere else, right? Yeah.
No, just PCB.
And I think this is going to be the thing that finally pushes me into buying a CNC machine. So, because I'd like to be able to CNC these parts instead. But yeah, look, it's been really fun experimenting with getting it all together and stuff. Also, people asked on the video, how does it hold this section down? And so the aperture of the holes on here are 5mm, and the aperture of the holes on here are 4. So that allows the suction actually sucks this onto the base and holds that on. So like it's kind of cascading as the holes get smaller and then they get blocked. And it's really cool. So yeah, I've been spending a lot of time on that, and just yeah. I've got some other stuff. I just don't know if I might do a tease. Should I do a tease?
Oh, do a tease. Do a tease. Yeah.
Do a tease?
Depends on what it is. If you have to stand up, I don't want to see it.
No, okay. I'm trying to think how I do a tease. Okay.
There was a suggestion of who's not wearing any trousers competition. So,
No. Okay, I'm just going to quickly hold something up to the camera, and then I'm going to. Yeah, that didn't sound good. Okay, ready? I'll stay sitting. Okay, here we go. I'm just going to put some logos on the screen.
Nice.
Do you,
Stay in focus.
are
Yep.
you using
Kinda.
additional serial chip, or are you using the built-in USB?
No comment.
Ah,
Oh,
It was a tease. It was a tease. Now, it's all native. I'm not doing external chips. If you want to, well, firstly, there's no room. But if you want a board with an external chip, buy one of the development kits.
Yeah.
There's these boards are absolutely packed in. No space for a second USB or for a serial. But you can always connect one externally. Like all the pins are broken out. But yeah, they're the first revision of my S3 boards.
do you know anything about the stuff that they released recently on the ESP YouTube channel? They showed that they support even USB cameras now and so on.
Yep.
Did you try that already, or?
No, well, no, because they don't have that stuff in their mainline IDF right now.
Oh, so it's like only a tease or what?
No, well,
Everybody's teasing.
No, so the native USB is a full speed on the go USB compatible, right? It always has been, even on the S2. It's not specific. It's not an S3 thing.
So the S2 also supports that.
Yeah, absolutely, right.
Cool.
So it's just that the IDF is quite late in all of their USB stuff. Like, for instance, all the mass storage stuff that, Tiny USB and CircuitPython uses for the native USB. CircuitPython's had that for a while now, but the IDF is only just now introducing things like mass storage and HID and other stuff. But yeah, it's a full speed on the go, and you can still use the native USB to flash the device, and then you can unplug it, and you could plug an on the go into it, like a camera into it. Like, you don't have to have two USB connections, for instance, like one with the serial UART to flash it and one for the thing. You just put the board back into download mode, and it just becomes a normal CDC again.
Did you think of a method to switch it on the board? Because when designing boards that use the internal, I would like to have, let's say, USB-C to upload it, and then maybe a USB a socket, a regular USB 2 socket, and I would like to switch it from when I boot up or program it to use USB-C, and then only use the USB-C power and switch the data lines to a port or anything on a board. Do you have any ideas about that? Is there a possibility to?
You could do that. You could just use you can use a high-speed digital switch for your data lines, I guess. You'd have problems getting something like that through certification, but yeah, you could do that. You can get a high-speed.
But there is nothing built in the ESP.
No, well,
like a matrix or
for an IO matrix for the data for the D plus and D minus. No. They're complete. No, you'd have to do that externally. But the solution to that is you stick a serial UART on there, and you have one to flash it and one, and you use the on the go as the on the go all the time. Yeah. But I mean, I don't know. If you look at all the other chips and all the other boards that have native USB, none of them have a serial UART chip on there. Right? The only reason that you can get their dev kits and stuff, if you look at this is the S3 board, the current dev kit, it's got two USBs on it now. They didn't do that with the S2, but they've done it with the S3. So they've got native connected and they've got a serial UART chip on there. Now, this is the only thing in existence in this whole marketplace that has this. Like you buy any other dev board or, like a Nucleo board, discovery board, or any other type of development board that has a SAMD or an ARM, like an STM32 or whatever on it, they don't break out 2 USBs. It's a native USB and you get 1 USB connection, right? The only reason Espresso are doing this is because up until now, every one of their chips has required an external serial UART, and that's what everyone's used to. But I don't know, like the fact that people are still designing with an external serial UART, for me, defeats the whole purpose of having a native USB. I mean, you can take one of, Paul's Teensy boards that's only got a single USB connector on there, and you can do all the things that you want to do. You can use it as a full on-the-go USB and whatever else, and still use it to flash your board. And you don't see anyone running out and sticking an external serial UART onto a Teensy board.
Yeah.
Like it's not needed. It's just that everyone is so used to doing things in a certain way with the ESP32 that they're coming out with boards like this that have both, but it's unnecessary. So that's why I've been focusing on only doing native on my boards. The flip side is, though, that all this stuff's still very new, and the IDF support for all the things like the on-the-go, the camera, full-speed camera, and doing HID and stuff like that is still only coming out now. The mass storage and everything else is still only coming out now. So yeah, they're a little behind in the software, but yeah, it's like, why do you need to have both connected at the same time, bitluni? Why can't you plug your USB in, flash it, take it out, and then plug your device in because your code's running on the board? Why do you still need to have the? Are you talking about for powering?
I need it as a host. So I want a console that is powered from the USB C connector, and then have plug in like keyboard or controller in the USB A, and then. But I don't want to program the ESP over the USB socket, like USB 2 socket.
Okay.
So I want a constant power supply. I don't want like an additional power supply at like.
But you're talking about making a custom board, because you can do that. Like all the pins are broken out. Like RX, TX,
but I want the USB-C to deliver power.
Yeah.
And programming the ESP32, and after it's done communicating, programming, whatever, switch to another port where I have plugged in my peripheral that I want to use with the computer that I made.
Okay.
So this is
so
like,
if you're going to have specific 2 USB connectors on there, why not just stick a serial UART chip on there with you as well, and then that solves it.
Yeah, but I don't want an extra UART chip if I can like solve it a different way.
bitluni's gonna spend like days trying to figure out this like high-speed USB switcher to avoid putting a 40-cent CH340G on his.
That's the problem.
board.
Chip shortage, like
The CH340G
you don't want
is
anything.
available.
You don't want to use any components beside like true hole resistors anymore. So.
You'd have to use another chip. You'd have to use a high-speed digital switch. Like
No.
Which is also.
No, I don't want.
You absolutely cannot do it inside the chip, inside the ESP32.
Yeah, okay, that was my question.
You could
Thank
maybe
you.
use jumper headers to move from one USB to the other bitluni.
Yeah, that's a solution, like a jumper.
I think this is very unique to you, though.
No.
You can do that. You need 4 jumpers. No.
Yeah.
4 pins.
Two
Four
jumpers.
jumpers.
Yeah, 4 pins. Yeah. Anyway.
Anyway,
3 pins even.
we digress. There's a quiz to do still.
Oh yeah,
Okay,
quiz.
that's it. I'm done.
Okay, Sean's down. All right. Well done, Sean. Thanks very much. That's brilliant. Good job. So, what's next then? I guess it's me next, isn't it? Me.
Yes.
Okay, right. Let's see if any of this actually works. Let's turn that on. Let's do that. Okay, so I know some of you have seen this already. This is the the old asteroids project. But I didn't show it when I came on the Makercast the first time. I was so nervous I forgot to set any of my projects up. So this is the
Oh wow!
laser projected asteroids. So there's a few issues with the sound at the moment for some reason. It makes a strange crackling sound, which not quite worked out why. But... So that's the laser projected asteroids. And
How many of those have you built? Have you just got the one?
oh, I've just got the one, yeah. And I'll show you the wire. Oh, oops, I'm disconnecting my phone. Hang on.
Whoops.
Oh, no, technical issues. Oh, there we go. So it's, the wiring is a little bit of a mess. The main problem is the controller I made, which is this thing. It does require. It's got 4 switches and this magnetic rotary encoder, which involves a lot of wires going back to the actual. I guess we can call it a console, to the console, and then you have even more wires because you've got the two wires that control the laser galvo, which is here. So you can see that. I'll try not to get the laser on my phone, but that's an X and Y galvo with
This
2
is one
little
that you can
mirrors.
get off AliExpress, isn't it?
You can get off AliExpress. Yeah, there's loads of them, and that basically projects our laser. You do get in a sensibly lit room. You can get it onto a sort of wall that's quite far away, and you get a kind of 4 meters by 4 meters display. So it's pretty good. And then in here we've got there's a custom board with a couple of DACs on it and a MOSFET for switching the laser on and off. And then these boards are what come with the actual laser galvo. So this is just a bunch of analog amplifiers that use feedback to direct these laser galvos. The laser galvos are pretty interesting. They're basically just sort of coils with electromagnets, so very lightweight kind of motors that can be moved very, very quickly. And they have a kind of, well, some of them have some feedback that uses a light shining on some other mirrors. And as the galvo turns, the amount of light being reflected back to 2 sensors changes, and then you can detect where the galvo mirror is actually pointing. And there's a bunch of crazy non-linear feedback circuitry that sort of checks where it is and tries to correct it. So you can get, these ones are really cheap, they're off eBay, and they're kind of, they don't cost very much, really. It's about £60 or so. You can get amazingly expensive ones that go up to really high frame rates. But this gives us quite a reasonable display. It doesn't flicker too much. Obviously, when you're showing it on the camera, you get the shutter effect, which means you get that flicker. But for me, it's kind of pretty much solid. It's a bit flickery, but you don't really notice it. The more stuff you have on the screen, the slower it gets. So as you get more and more sort of, well, there's not many left now because it will be shot. If I clear the screen and try and get a few more on, the more sort of elements you have on the screen, the slower it gets because you've got to draw more and more things. So that's now flickering quite a bit more because it's trying to render more lines, and there's only so much time these galvos can move in. So the more stuff you have on the screen, the more flickery it gets. But it's still pretty reasonable. Even now, it's not too bad. So that's the old laser projected asteroids. The other thing I thought it might be fun to show was I've been upgrading my voice-controlled robot to use one of Sean's tiny Pcos. So if we turn this on, turn this off so it doesn't make too much noise. So hopefully this will work. So if I say it's slightly got a mind of its own, but if I go forward, backward, left, right, forward, left. Then that's my little voice-controlled robot. Shit. Voice-controlled robot, which does tend to kind of move if you're just talking as well. So it's not very well trained, but it does kind of responds to commands. Backward. Yeah. So most of the time it responds to real commands. half the time it's kind of moving by itself. But that's a fun little project. So I've been upgrading that. Now I've got little batteries. I built this originally around a big USB power bank. So I kind of left a big gap for one of these tube sort of power banks, but actually it runs off a nice little 1,000 milliamp hour battery now. So that's quite good. And then the main project I've been working on is this DIY e-reader. Unfortunately, the screen's quite reflective, but let's see if I can get the right angle. Yeah, there we go. So that's a bit of Beatrix Potter, Peter Rabbit. So we click the buttons. Come on, okay. Oh, there we go. So I don't know if you can actually see that because it is pretty reflective. I'll tell you what.
Yeah, we can see it, huh?
You can see it. Okay. So yeah, so you can page through the book. Now I've just been working on making this work with. At the moment, it's using an SD card, but one of the guys on GitHub wanted to use spiffs, so I've been making it work just off spiffs. But you can only fit maybe 1 or 2 books, whereas when you've got an SD card, you can fit quite a few books. I've got about 20 or so on there at the moment. It is a bit slow rendering images and stuff. I've gone a bit over the top on the UI for picking books, so we can get quite a few books.
Some kind of known format of the files? Or?
Yeah, so they're called I'm using EPUB files, which are kind of a zip file. So it's a zip archive, and it has some XML files that sort of define the contents of the ebook, and then the actual sort of contents are actually HTML. So it's XHTML, so it's fairly easy to parse, and they tend to do them in quite small sections. So each kind of chapter of the book tends to be an individual file, and then there's images and JPEGs and PNGs. So it actually sort of works pretty well. I'm quite impressed with it. Renders so well. It is using a lot of PSRAM, so when you're parsing one of these HTML files, it does use about 1 megabyte of memory, so you do definitely need PSRAM. And then the e-paper displays tend to need sort of 2 frame buffers, so a sort of front buffer and a back buffer. And that's how the e-paper driver knows which bits of the screen to update. So it's really hard to fit it into a sort of standard ESP32. But as long as you've got PSRAM, then that works really well. And so yeah, that's kind of quite nice. Drawing images is a little bit slow. So when I actually hit an image, if this book has any images, I'll probably pick one that doesn't have any images. Let's go back. So it still needs a bit of work, a bit of tweaking will make this pretty good. So yeah, so that's my ebook reader, which has taken up, to be honest, it's probably taken up most of this month. When I was supposed to be actually working in the day job, I've been messing around with ebook readers. So,
okay, the boss now knows that.
Yeah, don't say that publicly.
oh yeah, that's been a bit of fun. So very, very interesting. But yeah, now I'm looking for the next project to do after this. So need more projects. But if anyone's got
a full backlog, anyways, if you want to do them.
You got a full
backlog you can take.
Yeah, well, that's the problem. I'm sure I'm going to get a lot more. Sort of, can think of many. Just lie in bed thinking of projects to do, and then I realise that I don't actually have that much time to do them. So,
you know, one thing that I actually I used to commute for my job like 2 days a week. I had about an hour and a half each way, and like that drive used to be a place where I used to like think through a lot of project ideas and stuff, like, you know, just noodle over things and like go through, you know, you wouldn't actually be trying anything out obviously, but like, you know, be like, oh, I could do it that way, or maybe I could use that, or maybe I could do that. I actually kind of miss that a little bit. Like, there's no sort of hour and a half of doing nothing anymore. Like, I know driving is not nothing, but it's not active concentration, really, especially on a motorway or something.
I've had the same thing. Like driving around the M25, I've designed part of that VGA circuit.
Literally with your laptop out beside you.
No, it's just there's sections of your brain that just aren't needed for driving, and they can just wander.
Yeah,
And
I agree.
If you're sat there at your desk, trying to looking for something to do, something to occupy your attention, it's that kind of, it's a completely different type of focus. There'll always be a kind of creativity you can get when you've got your mind engaged on something that's not taking all your attention.
Yeah.
And then suddenly you arrive at work and you don't remember the drive or how you got there.
Like my drive was literally like 5 minutes from my house was a motorway. Then it was motorway like for an hour and 20 minutes of the drive. Like, so, like there is really like, all I have to do is not crash into the car in front of me. I'd stay between the lanes. I get, like that's literally my two jobs. Like if I had lane assist, that would be half of them gone.
Yeah. Right. Are we ready for a quiz?
No. I have one question. Did you find about the laser projector thingies? Because I was looking into that topic like 2 weeks ago, maybe even.
Yeah.
Probably inspired by your videos, and I was looking for a Galvo that's a little bit smaller, because you have like the one that you showed, that's the typical one that you can purchase for like 50-60 bucks. And then the next smaller types that I was able to find are from like some websites from the manufacturer that are really tiny, and where you have to request a quote maybe. And if you have to request a quote, you can't afford it.
Yeah.
So did you and I was also, my mind was like going mad that I could maybe build them myself. You can like small hard drives, they have like very precise positioning of the head, so you have like an angle there on this main axis of the head. And I was thinking if you thought about that or tried it already to build your own Galvo.
No, I do have a bigger Galvo that someone sent me. So almost the opposite.
Oh, bigger.
Which is more, it's controlled digitally, so I think it might be better than this one, but smaller. Yeah, I mean there are people who build their own, so there's definitely sort of people who will make their own and stuff.
But you didn't find like a cheap source of like tiny.
No, certainly not sort of anywhere obvious.
Okay.
I think there's kind of these ones seem to be mass manufactured now, so they're the kind of generic ones. They're very cheap. So anything outside that starts getting very, very expensive very quickly. It tends to be aimed at the professional sort of laser show people who apparently have thousands of pounds to spend on stuff.
So are those units that are so cheap, are those the same that are built in the cheap projectors that are like $200 or so?
I suspect so, yeah. I think they probably are. I mean, they seem to be manufactured by multiple people, so there's almost a standard sort of, this is a laser projector Galvo.
It's like a clone.
Although, I mean, the original one, I had two, and I thought I'd broken one of them. It came with two separate boards for driving the X and the Y. And then this one was slightly more expensive and just has one board. So this is probably a later version, but it's kind of the actual hardware is exactly the same. And I think the electronics is exactly the same. They've just squashed it onto one board rather than two boards.
Okay.
So, yeah, it seems like it's fairly standardized, at least at the low end, to just this. I haven't seen anything much cheaper. So, but you can get good results out of these ones. Why do you need something so small? What have you got planned?
A smaller project. It has to fit in like this size.
Okay.
Maybe,
yeah. I mean, these are pretty small. I mean,
what's the like?
Hang on, 1 second. What are we looking at? It's about 4 centimeters.
They look bigger.
Yeah, 4 centimeters by 3.5. So it's a 4 centimeter cube.
How noisy is it?
It's very quiet, actually. I mean, you can hear it, but
I
it's...
hope you've affiliate linked these in the description, because I'd imagine loads of people are currently AliExpress searching.
I can
Galvan.
What is it? Then they'll be contacting
Of
me
course
saying,
you can,
"Can you help me
bitluni."
build it?"
No, I can't. I'm not a moderator.
How difficult to drive are they?
Well, they're very easy because the driver boards do it all for you. So you need to feed in a differential signal. So that's the only sort of horrible bit, is just getting a differential signal, which is just kind of one that goes either side of the zero. So, but you can drive them sort of single-sided as well. So it depends how much deflection you want. One of the problems is if you do...
Yourself?
Sorry?
Did you try to drive them yourself?
No, I didn't, because
Life's too short.
life's too short. Yeah.
Okay.
Yeah, well, the problem is the driving them is actually quite complicated, and these boards come with about, this one's got 1, 2, 3, 4, 5, 6, 7, 8. It's got about 10 little potentiometers that are tuned in the factory to adjust all the different non-linear kind of behaviors of the amplifiers to get sort of, they basically tune them to do this standard test pattern at a certain rate without any artifacts.
Yeah.
So it's a bit of a strange world when you start digging into it. There's lots of sort of voodoo and black magic going on about tuning these things. And
I was quite surprised how big that board was. Like,
yeah, I mean, there's a lot of there's basically a whole bunch of op amps on it. That's the op amps and then audio amplifiers. So it's kind of on the output stage, there's a couple of big audio amplifiers that they use to drive the actual galvos,
Right.
and there's a whole bunch of crazy feedback stuff. The really expensive stuff is all digital now. Oh, there we go. It's not as big as that. Yeah.
I could attach it to these.
Yeah, you could, yeah. I mean, you just need to generate sort of some analog outputs. So I just
for your next one-day stream, bitluni.
Yeah, that'd be cool.
It'll take you 1 week.
I don't mind the artifacts. I just wanted to like run and make a video and done.
Get the affiliate link. But bitluni,
The $60 part you can.
yeah, exactly. That's not bad.
You should do it. Well, it's great fun, and the playing with lasers is always good, isn't it? So get a little laser. I
No
did
laser
find,
in your eye.
yeah, well, that's the only thing that's worried me slightly doing it all is, but
How much?
I want to
power
see
does
multicolor, Chris. I want to
yeah,
see
multicolor.
see two
Well,
galvos.
yeah, I think on
Two
eBay
lasers.
there are there's some really nice RGB laser things that have.
Is there?
You got a red, green, and a blue laser, and they use prisms and partially sort of opaque, partially reflective mirrors to kind of combine them all together and then send them all out. So you
I
can,
think they use a prism or something.
that's it, yeah. So you get RGB color
Combining
lasers.
the lasers is better.
What was that, James?
I was just saying, combining the lasers before you put it into the XY Galvo is
Yeah,
it's going to be a lot
combine
better.
it all
than
into
trying
one
out
laser
multiples.
beam, and then it's pretty amazing. But yeah, then you're starting to get quite expensive.
Bitluni is like, but the more
Looney's thinking I should do this.
no,
This
the
is
more
great.
expensive I make it, the more money I can make off affiliate links.
So wouldn't they, if you did it beforehand, wouldn't the colors split?
Well, because they're lasers, and as long as you align it all properly. So it is the guy I saw building one of these was he was a bit crazy, but he was really kind of completely
Is that
kind of
his
fine
name?
tuning it with a little kind of screws to adjust it, so it was just perfect. And then
Right.
slightly dangerously eyeballing, was it correct or not? Which always seems slightly.
So you adjust them before they hit.
Yeah, exactly. Yeah, make sure they are all
And then
kind of parallel. Yeah.
Okay.
So yeah, but that's getting into the kind of extreme kind of people. I quite like the
It's
little
the, it's the same how 3 TFT projectors work.
exactly. Yeah, it's very similar. Yeah.
Because they have like 3 arrays with different
Mhm.
TFTs with different colors, and they combine it with like a prism or like mirror. That's
It's amazing. It actually works really. It's,
Can I just comment? Bitluni's getting lower and lower. Fall off the camera in a minute.
right. Shall we do a quiz then? Are we ready?
Yes.
Yes.
No, but
Come on,
yes.
I've prepared a quiz for you guys.
Quiz!
Okay, how do I do this? Share screen, window, right. Okay. No expense has been spared in this quiz.
Oh,
Look
wow.
at this.
There's even a
A quiz?
keynote presentation. So if anyone's playing along at home, just get yourself a piece of paper and you can write down the answers. Actually, if you're playing in the live cast as well, you probably need to write down your answers or something.
Paper.
Or you could use your computer.
Okay.
Get crazy.
Okay, I'll type it into my phone.
Okay. It's the quiz. Is there a prize, you might be asking? There's always a prize.
It's Galvo.
It's the admiration and adoration of your peers. So if you win, you just basically become the most famous Makercaster ever. So are we ready?
I'm just going to leave now, get myself a coffee, okay?
Right then. Question 1, computer history. Who was the third founder of Apple? Was it Ronald Wayne? Was it Ted Codd? Was it Elon Musk?
Hey.
Or was it Gordon Moore? You're not
Hey.
supposed to shout out the answer.
Oh,
Write it down,
Oh.
Sion.
Say B.
shout it down. Shout it out, write it down. It's the same thing, isn't it?
All right. Are we ready for question 2?
After
That
question
one's
1, probably not.
I'm just going to shout them out. Okay, go on.
Okay, you ready? So, question 2. IBM boss Thomas Watson allegedly said, I think there is a world market for maybe X computers. Did he think he would be able to sell 5, 10, 100, or 1 million? This was back in 19 something, a long time ago, back in the year.
Did they?
Okay, next question. It's electronics. What is this symbol? Is it a fuse, an antenna, a memristor, or a delay line? So what is this symbol? Okay. Question 4, it's the music round. I'll just turn my volume up so you can hear it. Was that used in Jetpack, Ant Attack, Night Law, or Manic Miner?
This isn't fair. I'm younger than you.
Oh, what a shame.
Well, at least some of
Hold on,
you.
54 question, please. I never had a ZX Spectrum.
Oh, no.
This is a real UK focused one, isn't it? Wasn't ZX
Yeah.
Spectrum
Yeah.
UK?
The UK.
I'm just glad I've got one question right.
All right, next question. It's another music question. Right. Was this used in Elite, Tetris, Halo, or Final Fantasy? Okay. Next question. Movies and films. There's only 10 questions, so don't worry. This will be over soon. Movies and films. Computers make excellent and efficient servants, but I have no wish to serve under them. Who said this? Was it Kirk, Spock, Bones, or Scotty? Okay. Question 7. All those moments will be lost in time, like tears in the rain.
I know this.
Star Wars, Blade Runner, Total Recall, or Hackers? Okay.
Hack the planet!
I know one.
Question 8. What variant of Terminator was sent back in the first Terminator film? Was it the B9, the T800, the Symbian S60, or C3PO?
If we got the TS80.
You need a flexi friend if you get a TS80. No, actually, you don't.
Question 9. The chips are down. What country makes the most silicon chips? China, USA, Taiwan, or Malaysia?
Okay, the first answer that jumped into my head is not on that list.
Oh,
Was it Ireland?
so this is from Wikipedia, so all answers are from Wikipedia. Okay, last question. According to Wikipedia, what percentage of chip production do cars consume? 5, 10, 15, or 20? Okay, that's the last question. Do you want to go back to any questions? Or should we do the answers?
But I can hear bitluni typing, looking up Wikipedia.
No, I'm not typing.
Yes, you are.
I can paste my answers right now.
He's
I
planning.
think I got the Terminator wrong.
Oh.
Oh,
You did
But I don't know the
Symbian, did you?
answers. It was too quick.
C3PO.
I have the TS80.
Did you?
TS100.
You need a TS100 and a flexi friend, yeah.
Okay, the answers. So, who was it?
Oh, I have the
I ruined that one.
TS80 here.
Third founder of Apple. It was Ronald Wayne.
Oh no.
He owned 10% and sold it when it was.
Thanks, Sion.
Sorry.
Yeah, thanks, Ian.
Does anyone know how much he sold his shares for?
Oh,
when he
yeah.
got out?
Bonus question.
It was like $10,000 or something stupid like that, wasn't
It was less than
$80.
$10,000.
it?
Yeah, it was. Yeah.
Okay. Where are we? Oops.
I got that wrong.
Okay, so Thomas Watson said there's a market for maybe 5 computers worldwide.
Oh wow.
It's only allegedly, though. Apparently, this might just be made up. So,
Seems like a stupid thing for the head of a computer company to say.
Can we stop counting now? 'Cause, like, I've got 100% so far, and I know I'm going to fail later.
That's a
what
delay
is
line,
this
isn't it?
symbol? This symbol is a memristor,
No.
the 4th component of the components, apparently. So, anyone know what a memristor does? No, I don't know. No. Okay, the music round.
It changes its resistance based on the current that's been through it beforehand.
James. Bonus point for James. There we go.
You said you weren't a hardware guy, James. I'm actually like a qualified electronic and computer engineer. Like literally have a degree. No idea what that was.
I didn't get the symbol. I thought it was a delay line, but I read an article about memristors a few years ago, and it stuck in my
Did
head.
anybody get this then? Who had a ZX Spectrum? No one.
I picked
I didn't
the...
know it. Oh yeah, I guessed right.
Yeah.
Manic Miner.
This is my first point. I guessed that one right.
Oh crap, I haven't been counting whether I got points.
Okay, the next one. This music was used in Elite for the docking computer.
Oh yeah, I remember.
got that one.
I played Elite on
Guys.
PC. They had always classical music.
You were quite clever there and stopped it before it got to the bit that played when you were actually docking.
Oh, did I? I never owned a Commodore 64, so I just kind of heard it. Okay, so who said this?
Scotty.
Anybody get this?
Phones.
Scotty?
Spock!
I
What?
said Spock, yeah.
Spock.
No way.
Yeah, sorry.
Wrong.
Okay, it's a bit
Blade
loony,
Runner
but this
for
one didn't
sure.
you?
Everyone got this.
Oh, I didn't get it.
Oh no! Ryan!
Ryan.
My wife does not like sci-fi movies, so I do not
And
watch
in your
sci-fi
geek credentials.
movies.
Oh, Ryan.
Yeah.
Terrible.
Like I've seen Blade Runner before, but like I don't know, 15 years ago.
Okay, I have
Okay,
800. Is T800
T800.
right?
T800's right.
Oh yes,
Yes.
please. Got
Yeah.
4 points so far.
Okay. So who got this one then? It's
Malaysia.
Taiwan.
I said Taiwan. No.
TSMC. TMSC. TMSC? No.
Where did you think it was, James?
For some reason, I thought it was Korea, but my second guess was Taiwan, and
Well,
Yeah.
there we
it was
go.
on the list, so that's all that matters.
Malaysia does actually manufacture quite a few chips. There's quite a few foundries there and design places. But Taiwan, mostly through TSMC. They are the big one. And then the last one, how much do cars consume?
I said D.
50
Yes.
cents.
By chance.
Yay!
What
I
was
got
question
50%
3? in the
right.
answer?
Oh man,
Three.
that's terrible.
Question 3.
No,
Members.
I got that wrong. Yeah, no, it's good. It's good.
How can I get 50% right even though I knew like 1 or 2 for sure?
Wow,
There's
that's
4 options.
Cool.
You'd only have a 25%
Oh yeah, true,
chance.
true. Okay, that's right.
Bob Hickman, 7 out of 10. So did you guys beat a member of the audience?
I
didn't.
got 7 out of 10 plus my bonus point.
Oh, yeah.
Oh,
You're smart ass, James.
I only got 5. You could be the super popular YouTuber of Makercast or whatever the title was. You can have it.
Also
I don't even want it.
I got 5.
I got 5 as well. Yeah.
Oh. Looney, what did you get?
5.
5. James,
Also 5.
you win the admiration and praise of all your fellow peers.
You don't have my admiration.
Electron Ash got
James.
8.
What have you got?
Thanks, Brian.
5
No, you're
days.
welcome.
Admiration and adoration of your peers. There you go.
James, you need to build in a memorista in your computer just for the jokes.
Yeah, but maybe James, you're on a whole nother level, so I'm not a peer anymore. So that's why the admiration thing is not there.
I think I had a bit of a bonus just by owning a Spectrum when I was younger.
I think the first computer I would have had is like a Nintendo, like a NES.
Wow, how old are you? You must be like 13 or something.
I'm 34. And I had the NES when I was young, like 4 or 5. Like I was born in 87. When did the NES come out? Like 90, right?
I don't know.
Okay, old now.
Like
Yeah.
Is this a bonus question?
I should have had a Spectrum when I was -1, or like, why should I have had a Spectrum?
I just thought it was popular knowledge. Sorry.
1990, that's 11 years ago, right?
Yeah, exactly. Yeah, the NES came out in 1986, so I'm newer than a NES even.
Wow. Yeah.
James, how long ago in Hex was it? He's working out. He's working out.
Well, I said 11 years, it was B, but
It came out around 1986. There we go.
It was probably in Japan. It came out in 1986. Didn't make it over here till. Well, Ireland needed to go through a boom of economic prosperity before anybody could afford one. So yeah, we probably just got everything later than everyone else. That's my economic talk for the day.
Okay. Next time, Brian, I'll shift all the cultural references forward by 20 years or something.
20 years? What? I'm not 20 years younger than you. NES was 1983 in Japan. Wow.
Wow. That's pretty cool. That's amazing.
Wow.
if we're going 20 years forward, will the next Makercast be on TikTok?
I'm not on TikTok, so maybe we'll contain me.
30 seconds to show their projects.
And it has to have some weird computer audio. Brian showed this project, and it was amazing. Like, what is with that voice?
Brian, we can set up a nice makeup filter for you. They track your face in real time. That's really cool.
Yeah.
You can do live.
They do more than track your face in real time. They track your data and bank accounts too.
You know you can do it even like a live stream on TikTok, so it's not far off.
Okay.
Maybe we should do Makercast.
Do we have a
Looney is suspiciously knowledgeable about this.
Sponsored by.
I might waste a little bit of time on TikTok from.
So the real reason bitluni hasn't released a video in like 9 months is because he spends all his time on TikTok.
He's been learning.
I'm doing research. It's research.
The YouTube shorts The YouTube Shorts algorithm is not good.
Oh wow, there is no like clickbait filter whatsoever. I get only like
That's not the problem. But like, you watch a video and like, oh, you watch one guy make an ice cream or something, and it's like for the next like 20 things, it's like, here's a guy making an ice cream. It's like, I don't care about ice creams. It was just one thing. It's not sorry.
One time.
Yeah, I take it back. I take it back.
Whereas we just get people wiring up PCBs and breadboards. So
Yeah, but like I have come across some people from the scene. Bitluni has a shorts channel, but a couple other people as well have shorts, and you come across them.
what,
like 3 views on my shorts.
Yeah, I'm one of them.
No, it's
Oh, you.
automatically like pasted on my Discord. Nobody watches that.
Gotta get that engagement, Bitluni.
Oh, I don't care.
He's living off the affiliate money of these future Galvo videos.
yeah, that's it. What's the most expensive Galvo you can buy?
Let me
No,
reveal
I
it.
think this is a gold mine here.
You get the hell away from that, Bitluni. You get the hell away from that. That's my gold mine.
I don't know. I'm pretty sure making computers that fit on a tabletop is the gold mine.
Please.
Yeah. When it comes in kit form and it takes you 18 months to build it. Yeah.
Yeah, whoever I pick to be the supplier on that will be the new #1 chip manufacturer in the world.
Sorry, I missed it.
Like, what was the worst time in the world to make a discrete logic CPU? There's a silicon shortage. Yeah.
I've not had any problem getting hold of discrete logic
That's
devices.
because
Oh,
you're
yeah, that's-
using chips from like
I was
Soviet
surprised
era.
as well. Usually back in the time, it was really hard to get like the true hole components and the logic ICs. It was harder to get those, and they were like way more expensive than the surface mount thingies. And now it's completely different way around. Building like that board, this driver board, it was so cheap. This is like the BOM cost is maybe without the ESP, it's like maybe €5 tops.
Wow.
So it's
Nice.
really cheap to
If
do
you-
true old stuff right now.
If you get the bulk ones off eBay, what you'll actually find is that an awful lot of those come from reclaims from old PCBs.
Oh, really? Yeah.
And the worst suppliers of those, what they literally do is they just hold the boards over a flame until the chip.
Hot
And then
plate. No.
They collect them up and reprint the top so they all look nice and new.
Things I learned.
I've bought lots of cheap discrete logic chips, and some of my most, I'm going to say, enjoyable debugging sessions have resulted in me finding chips that are a different 7.4 series logic chip than what's written on them, and occasionally just dead.
Oh.
Wow.
That's hard to debug.
Yeah.
How did you find out though? By popping the lid, looking inside?
No, it's I think I had a NOR gate that was labeled as a NAND gate,
Ah.
and of course, a more complex chip I would have just regarded as dead, but that was like the logic function on this just isn't right, but it's obviously it's the wrong chip.
Right. Okay.
They've misidentified it and printed the wrong label on top.
Is there some kind of tester that you could use for that, or develop a tester for
I
logic
have
chips?
thought about making a tester for that, but yes, it's in the backlog with 100 other things that will probably never happen.
Okay.
Mm.
Yeah. Know that feeling. Yeah.
Me too. See
The
that board
problem
back
is when
there?
you start thinking about what it
Like
needs to
that.
do, you get feature creep to detect all the odd variants of stuff.
Bitluni's looking for more ideas to steal.
Yeah, that's it.
He can steal that one, and then I can buy one because it would be quite handy.
They must exist, don't they?
It's got yeah, there must be something that does that. You got these you got these things, haven't you? The little
Zip socket.
PCR testers. Oops.
Yeah.
Yeah, that's not working. Yeah.
That looked like an Etch-a-Sketch.
I was thinking that might be my next project. Because I got this e-paper display and I thought, it looks kind of like an Etch-a-Sketch. And you just need a couple of twiddly knobs. Some
rotary encoders.
A couple of knobs.
Next week on Bitluni's channel.
No, there's not enough affiliate money in them.
Oh, the big e-ink displays are pretty costly.
That's true. Yeah, Bitluni is like,
Yeah.
But hang on, before we talk about how much affiliate money Bitluni's made off his CNC video, right? Let's talk about how many robot vacuum cleaners you've sold, Brian.
Oh yeah,
okay.
His lawnmowers.
So
Yeah.
right,
We want numbers.
in the last right. So I released that video 3 months ago, or maybe 4 months ago. For the first month and a half, it did absolutely nothing. Got 1,000 views in the first 2 days and did nothing after that. And then it was like somebody in Google just turned on a switch and suddenly it was getting thousands of views a day.
120K it's up to now.
Amazon, which is the only place I had affiliate links for those, have not paid. I haven't met the threshold on Amazon for affiliate links since that video came out. So I haven't actually went in to see how many people bought them through links, but I have not made over, I think the threshold is like £20 and $30 or something. It's nothing.
No.
I would have thought one sale would get you over the threshold. So I don't think I've had a single sale. But one thing that is
Amazon
interesting,
is a scam. I think, Brian, they might have been somewhere a sale or something for the specific
maybe,
mod
yeah.
that you have.
But one thing that is interesting, that it makes more money ad revenue than my other videos. I have the first video I did on the Matrix displays has 160,000 views and has made half the money the robot lawnmower video made in its lifetime. Just because if you think about it, if you wanted to put an ad in front of one of our channels, what do you put in? You're trying to aim for a techie person, maybe, as in what do you put in front? But if it's a video for garden tools, Ryobi, you'll want to get involved, as in there's the target audience of that kind of a video is much more valuable from a marketing point of view. So they're paying out the big bucks. So I'm a robot lawnmower video channel now. Nothing but robot lawnmower videos spearheaded.
And Brian, I didn't earn much from the mini mill. It was sold within 2 days or something, sold out. So they didn't have much stock there, so I didn't earn much. You need to just partner up with the next one. Make sure. I didn't accuse you of anything. I think the best deal was the light placer was the best deal for the light placer guy, because that had this link was clicked 50,000 times, and then you have a conversion rate of 1% probably. Then you can imagine, and one of those things cost 2,000 euros. He was really happy after a month that he did this deal with me.
Yeah.
But other pick and place manufacturers didn't want to. I asked what was the other guy, Sion?
Sharman.
No, the European guy that also does the tabletop. What's the name?
Oh,
he didn't want.
Yeah, SM Small.
Yeah, small SMT or
Yeah.
something. Yeah.
Yeah.
He didn't want to put one on my table.
No.
That was a loss for him.
Yeah. But they start at like 4,500.
Yeah.
I mean, different.
I don't know.
It's their loss.
Okay, we
loss.
are talking about YouTuber stuff again here.
Yeah, that's just
Audience already faded out.
tuned out. Okay. So is that it? Are we done? 2.5 hours?
I think we might be done. 2.5 hours. That's not bad, is it?
Pretty good. That's pretty good. I thought James's section was going to go for 2.5 hours at the start. Mine
wasn't the longest this time, Brian.
Wow, that's
You could have
impressive.
tried harder. It's very disappointing.
That's because he was listening more than he was talking,
I was
could get
even
ideas to steal.
fixing this thing, but it still doesn't work. I don't know what. I saw that while someone was talking, and yet it won't work.
Bitluni, I got a request. Can you put your end of your stream music on for the end of this stream?
Oh no, I can't, because then I would have to switch the microphone. Sorry.
Okay.
I can play the Manic Miner song again.
Yeah, Chris, do you have music?
I've lost it now. Okay,
Who can hum the bitluni music the best?
What does the Bitluni music sound like?
I can't sing at all.
I'm so tempted to use that in a video unironically.
Do
Just
it.
be like,
It's in the YouTube library.
yeah, I
You
know.
can
Like, you
take
can't
it.
do anything about it. You don't own that song.
Yeah.
I own this song.
Yeah, you get a copyright strike. You get a copyright strike from Bitluni.
Yeah.
The Mario music could be more up my alley. No?
Okay, well,
That was the show.
yeah.
Well, thanks everyone. That was brilliant. Awesome show. You've been brilliant.
Thanks for joining,
Been amazing.
everyone.
Thanks for coming, everyone.
Thanks,
See you
everyone.
next time.
See you next
Bye.
time. Bye. Bye.